This is a demonstration of the reified execution system that's part of the Lively project. Over here on the left side you see the definition for a function. It's pretty simple. It counts up to 4, and for each step it logs its counter, and when it hits the counter number 3, then it will stop the execution. So when we define that function and we run it, we will see we count up to 2, and then we hit the debugger and we stopped. What happened here is that we created sort of an object for the execution that captures both the internal state that was part of the execution, as well as it gives us a new entry for continuing the execution, and other methods. For example, we are able to copy the execution. Let's do that, and let's resume the original execution. You will see we continue to count and then basically exit that function. But we can also go to our copied version here, and we can run that, and we will see it continues at the same point. What happens behind the scenes here, let's print the what's actually going on. What happens behind the scenes is that we take the original source code and we rewrite it in a form that each of the syntax nodes that we get when we pass the source code gets sort of an assignment of a counter. Think of it as a program counter, like a pointer into the execution. So here we can, for example, see that when we hit the counter number 3, we enter the if statement, and our program counter then is basically assigned the number 13, and then we throw sort of a custom exception that takes the program counter as well as all the local state of that function, and basically unwinds the stack. And we look at the syntax tree over here. You can see over here we enter the we create a scope. We see the scope of the entire function, and we can follow the syntax tree down to the debugger statement over here. And what happens when we continue the execution is we simply skip over all the nodes that have a program counter that is sort of smaller than the program counter that we stopped at. And first, when we reach that, we fill the state of the variables that we already know from the first execution, and then we simply continue the execution at that point here. So this has a couple of applications. So as you see, you can sort of objectify the execution, either to copy it, to inspect the actual state. Think of an application like in a debugger. You can do step-by-step debugging here, and have like an inspector for local state. But of course, you can also take the execution and send it over to, for example, another JavaScript VM to run it. Yeah, so there are various options here.